Okay, in this section we're going to be talking about rational exponents. Rational is just another way of saying that it's a fraction with integers, and so you have a ratio of integers. So an exponent doesn't just have to be a whole number. Sometimes you can raise things to a power that is a fraction. The main thing that I usually talk about whenever I talk about rational exponents is if you can think of this fraction in the power as flower power is what I usually say. The number in the numerator of the fraction of the exponent is the power, or what you're raising it to. The number in the bottom of the fraction of the exponent is actually the root, and we've been talking about nth roots, cube roots, square roots, fourth roots. So as long as you can rearrange those, you're good. So if you take a number and you raise it to a fractional exponent, p is the power, r is the root, you can rewrite it, okay? Here's another way to kind of evaluate it. I just want to make sure that you understand. When you're taking a number and raising it to a power and then dividing it into a root, you can do it in either order. In this case, I wanted to raise my number to the power first, then take the root. In this case, I wanted to take the root first and then raise it to the power. So you can do it either way. That's fine. So let's get an example. So if I have 1,000 to the 2/3 power, this is my exponent. It's a fraction, but it's weird. That's okay. So that means 1,000 to the 2 power, flower power, and the third root. Okay? So I get to choose which one I want to do first. So let's say I wanted to raise it to the power first and then take the root. So that means I'm going to evaluate this to the power, which is a really big number. I don't normally recommend doing the power first and then the root, but sometimes it works out. So now I got to factor this out to try to get 3 of something to pull out. In this case, I had 3 hundreds, so therefore I can pull 100 out. But what if I said, hey, I want to do the root first? Let me do the cube root of 1,000, then raise it to the power. Because again, the numerator is the power, the denominator is the root. So here, I'm factoring out 1,000 into 10 times 10 times 10. Ooh, the cube root, I'm looking for a set of 3, so that gave me 10. So the cube root of 1,000 ended up being 10. Now I want to square it, and 10 squared is 100. Sometimes doing this one first gives you smaller numbers to work with. So just thinking about that. Here's another one. Here's a base raised to a rational exponent. 3 is the power, 2 is the root. So if I decided, hey, I want to take the square root first, this 2 means square root, and then I want to raise that number to the power. So I'll go ahead and factor out my square root, pull it out as a 4. Now I'm going to raise it to the power, and I get 64. If I had done it the other way and said, hey, I want to cube it first, then take the square root, it's the same problem, just done a different way. You can do that. You get larger numbers. That's okay. So I have 16 cubed. So I have 16 times 16 times 16. Hey, I already found a pair. I don't need to go any further because I found a pair. But here I need to find another pair. So 16 times 4 is actually 64. And then we got to take the square root. Oop, I think we forgot to do that. Okay. So then the number is 8. All right. So let's try a couple. Okay. So basically the power of -8 and the whole thing is raised to the power. So it's the same thing as saying -8 to the 1 power and the cube root. So I like doing the root first and then raising to the power, although in this case it won't matter a whole lot. I'm looking for a set of 3 of something. This is odd, so I can find a set of 3. -2 times -2 times -2, because negative times negative times a negative will give you a negative. And this, so I get my -2, raise it to the 1 power, and I just get -2. Once again, I take, this is not part of the exponent, so I'm just going to keep it out here, and I'm going to look for the 5th root of 32, and then take that number and cube it, okay? So I'm looking for 5 of something. So this is 16 times 2, and then 4 times 4, and then I got 2 2s and 2 2s. So all together I have 5 2s. So the 5th root of 32 is 2. I'm going to keep that negative on the outside. And then 2 cubed is 2 times 2 times 2, which is 8. And the negative stayed on the outside. All right, so I'm going to work this problem a little bit over here. Okay, so the cube root of 8, I'm going to do that part first and then raise it to the 4th power because the top number is the power and the bottom number is the root. So we already know that 8 can be divided as 2 times 2 times 2. So the cube root of 8 is 2, and to the 4th power means 2 times 2 times 2 times 2, and that becomes 16. Once again, I'm going to do the root first. So the square root of 25, and then I'll raise it to the 3rd power, or cube it. And the square root of 25 can be expressed as 5 times 5. So this is 5 cubed, which is 125. Again, this negative is out front, so he's not part of this exponent. So I'm going to take the 4th root of 81 first, and then cube it. All right, so I'm looking for 4 of something. So this is 9 times 9, and this is 3 times 3. All right, so hey, I found 4. So the 4th root of 81 is 3, and then I want to raise that number to the 3rd power. So 3 times 3 is 9. Whoops, I forgot my negative. Times 3 is 27. So my answer is negative 27. Let's talk about negative rational exponents, because now we've talked about negative exponents, we've talked about rational exponents. Now let's put them together. So the negative rational exponents are kind of like the negative exponents, it's just that there's a fraction. So in this case, instead of having like 36 to the negative 2, it's 36 to the negative 1/2. Again, this negative only means take what you were doing and flip it to the opposite side of the fraction. So since this is technically in the numerator, because there's an imaginary 1 down here, you're just going to take the whole thing and put it in the denominator and get rid of the negative. Now I can say 36 to the 1 power and to the square root. Well, 36 to the 1 power is the same as 36, so I just need the square root of 36. It's still in the denominator. And since 6 times 6 is 36, and I'm looking for sets of 2 because this is the square root, that's what I get. Once again, I'm going to take this, look at the negative, and say, ooh, I'm going to flip it. 3 is the power, 4 is the root. I'm going to do the root first to get smaller numbers, and then raise to the power. So I'm looking for a set of 4 of something. So I use my factor tree, and I find 4 2's. So the 4th root of 16 is 2, and I'm raising it to the cube power, and 2 times 2 times 2 is 8. What about if you have variables? Okay, let's take a look. Is 5 and x part of this exponent? Well, not the way I wrote it. Let's do it this way. Sorry. Okay, so the whole thing is supposed to be raised to the negative 1/3. My apologies. So that means take all of this and raise it to the 1/3, but now it's going to be in the denominator. Okay, so that means that it's the cube root of all that stuff. So we just leave it like that unless we're asked to simplify it in a different way.